Okay. All right. Recording is on now.
Okay. So, yeah, welcome everyone to our second webinar of our series of Craft Research Coordination Network, co-creating research for just Arctic future infrastructure transformations, resilience, and adaptation. This webinar is supported by National Science Foundation and a joint effort of several initiatives. Next slide. Vincent, can you go to next slide? So yeah, it's a joint effort of navigating new Arctic Community Office Convergence Working Group, Infrastructure Futures, and then RATIC initiative, which is Rapid Arctic Transitions due to Infrastructure and Climate Change. And also we are collaborating with Ararat's Native Council and with Native Village of Mikoyak, and working together to discuss the most pressing issues of infrastructure involving communities and other stakeholders. And today we are talking about engineering issues of infrastructure, and our host of today's meeting is Xiong, and I will give him the floor. So probably next slide.
Should I start?
Mm-hmm.
Okay, thanks very much. Happy New Year, everyone. Hope you're gonna start off with the most exciting and prosperous 2025 ahead. So, like Vera mentioned, this is a group of researchers, community leaders, and also a lot of key partners put together for justice, just infrastructure for the Arctic community. So today's with a focus on engineering. So we're fortunate to invite three distinct panelists for today's webinar. So there's a Baxter Bond from Alaska Center for Energy and Power, a Billy Connor, a director of Alaska University Transportation Center, and also Uyemaa Gantulga from George Washington University. So like so we tried before, so the format would be we'll have each panelist introduce themselves and also give some remark about the topic of the day, which is a kind of how engineering research can shape the future of Arctic infrastructure. Okay. And then we that the individual remark will be followed by like a discussion among the group, especially with like a panelist, to share perspective, maybe raise questions between each other, and also any attendees can also share questions. Okay, so maybe without further ado, can we start from Baxter Bond? And we'll start with a brief self-introduction and share some of your ideas.
Thank you, Xiong. Vincent, could you move to, yeah, so this is our outline. Next slide. Next. And next. Yeah, okay, thank you. So, Bax?
Hi, everyone. My name is Max Bond. I'm a research engineer at the Alaska Center for Energy and Power. I went to UAF and I graduated with my first degree in Uyemaa language in 2017 and then a mechanical engineering degree in 2018. And I am currently studying electrical engineering. And yeah, I have a pretty varied background outside of engineering. I'm a semi-professional photographer, and me and my wife have 3 labs. We love our dogs, and yeah. So I'll be talking more on the electrical engineering side because that's where my expertise is. So can you go to the next slide? So one thing that I've encountered a lot is that while a lot of renewable energy technology is technically feasible, it's often not seen holistically, like in long-term maintenance or in community feedback. And Kotzebue has pretty much proved that renewable energy technology is possible at really high latitudes. They're almost at 70 degrees north, but in order for them to have got there, they've been testing out technology since the 90s. They were one of the first wind diesel systems to be commissioned in the mid 1990s. And there is a really big disconnect between the technical knowledge of electrical engineering and like what it takes to maintain a grid. And it's often harder um, to be able to afford the costs that are associated with running a more complex grid system rather than just diesel. Next slide. So one of the ways I've seen being able to navigate that is to have these inter-community organizations. They can be very multidisciplined, like Canada Chiefs Conference. They do everything from fisheries to housing to energy to heating. They aren't they aren't pigeonholed, but they're also a really big conference. Most of the land area of Alaska is in TCC. And then you have the pioneers like at AVEC. Um, so when the Great Depression happened in the 1930s, one of the outcomes of that was the Rural Electrification Act. And by 1959, more than 90% of rural homes in the lower 48 were, or they had electricity. But um, the vast majority of villages in Alaska didn't see first light from electricity uh, until almost 1970, and AVEC was a big pioneer in that. There's also the Burrow side, Northwest Arctic Burrow, which is where Kotzebue is in, and then a really interesting case study is the Janina Wind Group. They were a group of four villages that came together and they pooled resources and they were able to install wind turbines and wind to heat technology. Next slide. And so I've read a lot of history about a lot of different things regarding infrastructure in Alaska. And often when we talk about being able to harvest renewable energy, it's kind of a lot of people get stuck um, in this idea that we have to have the perfect resource throughout the whole year. And in many cases in Alaska, that's just not feasible. And one thing that I've thought about was when people subsist, they go after what's in season. Like if it's not moose season, then they aren't going to hunt moose. And a really interesting case of this is wave energy in Yakutat. And the top graph is uh, modeled solar energy output, and then the bottom is wave energy, and those are decoupled. But if you use that in the right way, then you can offset a lot of diesel. So instead of optimizing, we're offsetting diesel. And then this Alaska Water and Sanitation retrospective, which was published in 2015, talks about how hard it is to get water and sanitation in rural Alaska. And what's really interesting is that a pretty common technology here in Fairbanks is um, is we have individual sewage processing plants at a lot of the homes. I have one, but those need a lot of support to be able to continue working at the extreme temperatures that Fairbanks sees. And something that was published almost exactly a year ago was the unmet needs of in environmentally threatened Alaska Native villages. And one of the big conclusions of that was that a lot of the funding is not need-based. It's merit-based. So if you've gotten awards before, you're more likely to get awards now. But that system just doesn't work up here in Alaska. And those are my 3 slides. So thank you.
Good morning. I'm Billy Connor. I'm currently the director of the Arctic Infrastructure Development Center at the University of Alaska Fairbanks. I've lived my entire adult career in Alaska, some 55 years. And as part of that, I consider myself a practicing engineer, not a research engineer, although my title says I'm a research engineer, but I kind of blend those two together. And one of the things that when I'm working with the tribes, I always try to keep in mind um, that the Arctic really isn't a cold and hospitable land. It's really the home to a hardy group of folks who truly love the land upon which they depend. And our infrastructure really needs to recognize that. I've retired from Alaska Department of Transportation after 30 years and have been with the university for the last 20 years. Can we have the next slide, please? And what I want to talk to you about is uh, as an engineering, a civil engineer, we're taught to not only meet the physical needs of the infrastructure, but also meet the cultural needs and the welfare needs of the people that we're serving. And in order to make sure that we do that, we have to understand a little bit about the culture of the North American Arctic. First, the native population is family and village over self, where the Western community tends to be the opposite. They're very much a subsistence lifestyle. They depend on the land and the resources that the land has. Little or no road access. Most of the villages are served by air. Few are served by barge. Few jobs out there, and the skill sets are somewhat limited, as you will. Overcrowded houses and aging houses, and I think that's becoming, well, I know it's becoming a bigger and bigger problem. We have 3 generations living in a home, 10 people or plus in some cases, and most of those houses out there, many of those houses are 30 plus years old and have not really been maintained very well. The sewer and water systems are strained at best, and we're living in an area of changing landscape. Next slide, please. Okay. One of the things that I've found as I worked with these communities that we have to be able to establish a meaningful relationship to get the information we need to do our design. That means gaining trust, and that doesn't mean just go out there, meet with them one time, go away, and do your work. It probably generally means multiple visits and takes a little bit of time. It's good to experience the culture. Go fishing with them, as we did here in Utqiagvik. Work with them and learn some of the dances, all of those kinds of things. Listen and understand. Spend some time with them and talk to them one-on-one. Share experiences and knowledge. And one of the things I find really helpful in coming up with the infrastructure and making sure that it meets the needs and culture is to offer options rather than recommendations. That seems to go a long ways in being able to get buy-in from the people who live in these communities. Next slide. I think it's really important for us to understand the link between the infrastructure and the culture. They're really synergetic. Ideally, the infrastructure reflects the needs and desires of those who live in the community. However, we have to recognize that the culture is influenced by the infrastructure itself. overcrowding houses leads to social issues, and adequate housing, it offers hope. I was in Point Lay a couple of years ago, and they had just built a brand new eightplex. And there was a young lady, probably 8 or 9 years old, walked out the door, walked out on the street, and I asked her how she liked their new housing, and she got a big smile on her face, and she says, "I've never had running water." And I looked at her and said, "Does that mean that you can shower as long as you want?" And she gave me a shy smile. But the point is that she had a whole different outlook on life as a result of the housing that she had now been afforded. Lack of transportation leads to isolation and high costs. Good transportation can lower the cost, but it also has an impact on the potential for cultural changes. And we have to recognize that. And one of the things that I'm seeing a lot that's missing in our thought processes is we do not do a very good job of taking into account the subsistence lifestyle in the homes that we build and the facilities we build, because there's no accommodation for food preparation. I've seen a number of the residents of these villages working on their snow machine engines on the kitchen table because there's no other warm place for them to work. And so we may want to rethink how we are providing those facilities. Next slide, please. And I want to leave you with it's really, I want to leave you with a thought. And that is, and I often tell young engineers this as we're talking in an effort to get them thinking a little bit beyond the numbers and what this infrastructure really means. And that is, the best engineering solution may not be the right solution if it doesn't accommodate the needs and desires of the user. And it's really easy to get caught up in that, coming up with the most efficient, the most optimized engineering solution, and just totally miss the boat as to what that infrastructure is supposed to provide. Next slide. So I just want to leave you with the concept. There are a lot of problems in the north. We're having failing infrastructure due to climate change, due to thawing permafrost, due to flooding, coastal erosion. All of those things are important, but I encourage you not to miss the opportunities that we have to provide infrastructure that is truly meaningful to the people.
Great. Thanks, Willie.
Okay.
Yeah, Uyemaa, can you carry on?
Hi. Okay. Can you see me? Okay, you can share. You
We
can
have
share
your
the
slides.
presentation. Yeah,
Yeah.
you can start the slides.
Can you start with your self-introduction?
Yeah, my slide includes that in the first section.
Okay. Yeah, it's on screen right now. Yeah.
Okay.
We will have
Uh,
you share the presentation with Vincent.
Oh no. Okay. Let me do that right now. I'm gonna share my screen and
Okay.
that should allow me to present. Okay, hi everyone. My name is Uyemaa, and I'm a graduate student at George Washington University. So here's a little bit about me and my Okay, so I've been working in Mongolian government since 2016 at the Ministry of Energy, at the Asian Development Bank, in different capacity. And I have built two 10 mega solar power plant, uh, sodium sulfur battery storage that is piloting in cold regions and originally from Japan that is climate very friendly. And I have also designed 500 kilowatt off-grid systems. I given approval review for 10 plus renewable energy projects, and I've consulted last year I consulted on Mongolian government and Asian Development Bank 250 million climate finance deal. And right now the disbursement is 100 million is dispersed to Mongolian government to enable climate finance in agriculture and energy sector. And I have been I created this Facebook group or this social group of over 5,000 Mongolians who likes to design new things and all that. And I also, in my free time, I like to do join like-minded communities, and I've developed a lot of community engagement projects as a volunteer. So, okay, I wanted to talk a little bit about what are the climate similarities between Arctic region and Mongolia. Both have, this is Mongolian, this is me riding the horse, and the second, we're in the western side of Mongolia where the tallest mountains are. And it's cold, and also we are covered with permafrost. 20% of Mongolia is covered by permafrost, and we suffer from natural disasters and extreme weather events. And so this is a photo from one of my my power plant that is generating electricity in the western side of Mongolia. One thing about the western side of Mongolia is that it is high altitude. It's actually in its own weather zone where it's a lot of lakes and but a high pressure climate environment and dry with alta mountain wind. And it's very remote, and it was 100% dependent on Russian power and diesel generator until we installed these systems. Now it mostly runs on renewable energy, and by 2027, this region will be 100% renewable energy run because we will have hydropower plant integrated that is stabilizing. So one of the considerations that I had to take during design of this is that logistical transportation cost, because the road is not paved from capital city until to that location. So and also some parts of the environment was also sensitive, and we were following Asian Development Bank's regulations to consider uh, the local environmental sensitivity and vulnerable ecosystem impacts. And also we have to, because it was located in one of the extreme climate locations, we chose this location because it was closest to the substation that was weakest, that would required power source, and the other geographical things we had to adjust to that. And so we had to do a lot of calculation on that one. So those are the big project design considerations. But I have also done a small system design, and then these are the considerations that I have taken. Okay, so weather-resistant materials, if possible. Actually, one of the things that I understood was that in high altitude and dry and very cold temperature, solar panels thrive. They produce higher than their specified amount during those. And then Mongolia had a very long clear sky days. But also this is an experiment that I've run in Mongolian its coldest capital city is Ulaanbaatar, Mongolian capital city, and then we run and then installed the battery-powered solar panel system to heat electrical heater in household. And we placed the battery system in three different locations, one outside, three different battery in two different locations, one indoor with casing, weather resistant casing, and one outside underground, and one inside without the weather resistant. And so okay, and this is one of the underneath. This is one of the cases where people, if you don't consider the local specific impact when you're installing, for instance, this was installed on top of this building, but this area is very susceptible to this weird wind pattern. So this was, although it was mounted very sturdily, the wind threw it up in the air and threw it in the front of the house. Fortunately, no one was hurt, but I was called to fix the problem and figure out why it was happening because this was the second time they've done that, when I did simulation, I understood that it was this specific, not a mechanical load problem, it's specific to the wind characteristics. So that's one of the thing, optimizing the resources, but also ground truthing the data, meaning that specific to their location, we have to consider what resources are the optimal and how we should be installing them. So that is also about the local knowledge, because the herder people already told these people, household before, this is a weird wind area, that just so you know, but they had kind of ignored them, which they could have saved money. But yeah. So next, oh, sorry. All right, so this is one of the project. Can you hear the audio from the video?
Over
Okay.
now.
Now?
Have you played?
No. Probably you need to stop sharing and then start again with audio.
Uh-huh. Okay. So this, okay, let me just go out. And this is a project I've designed that later on with my friends and collaborated and installed that later on adopted by the Mongolian government and UNDP. But the initial funding was from Asia Foundation and Eureka. It's a startup in Mongolia on carbon financing. So what we did is that we installed these small household systems in 5 different locations, 5 different environments. And then we piloted if we can heat that system in a cold region and then use this heater with sensors inside Mongolian gear. So we insulated the Mongolian yurt at the small dwelling, and then we installed this a heater that has a stone as a storage. So meaning that during the daytime they're heating the stone that it can transit, still heat the house even there is low sunshine. But we also had battery system where we were able to also provide so that families didn't have to burn the coal. We're one of the biggest air polluted cities that is bringing a lot of unpleasant consequences. And so we chose these single moms living with her children less than 3 years old, and we piloted. And then one of the beautiful thing is that we were able to finance their system cost by selling their carbon credit on the Eureka's market. And so that family actually had generated an income by going into this pilot system. And um, so one of the beautiful thing about this is that although like it was very complicated and difficult to implement when not a lot of people understand what you're doing, but after we've piloted the first winter, in the spring, the single moms were happy, and they were also they didn't. So the thing is that when you're living in this environment, you have to wake up before your children wakes up and heat the house, and then if you're not in the place and then you have to come back consistently to heat the place because it loses the heat. But she had now more time to focus and sleep, and so her tendency towards her children improved. She does because she's not burning coal anymore. She doesn't have to clean as much inside, and also it was very safe for the kids too. So, all right, that's the project. Thank you so much.
Excellent. Yes, thanks for all the panelists for the excellent observations. I think there's some commonalities from all the experience shared, like for example, in the Arctic region, the cold region overall, that's definitely unique climate and geographic challenges for the engineering technologies, from electrical engineering, from civil engineering, and also for renewable energy. And then there's many of the panelists also mentioned the culture is an important factor in the consideration engineering solution. So yeah, maybe we can just continue on all you have observed, have some brainstorming discussions on all these aspects. I think we have the three major questions raised to the panelists. So overall, towards how engineering research can shape the future of Arctic infrastructure. So maybe from the more specific for the three questions we raised, the first one is what's the most surprising community need that demand engineer solutions? I think you talked about like electric aspect, civil engineer aspect, and also a renewable energy aspect. Do you have a more like examples that you're interested to share with community with the group?
Okay, I'll start out. Bill, thank you. There are so many needs that the folks out there have, ranging from energy to water and sewer utilities, flooding, erosion, and thawing permafrost. But if I had to pick one issue that is probably most pressing with the communities right now, and that's the lack of housing. Um, in the North Slope borough alone, I think I heard the figure of 700 houses that are needed now. Those houses are going to cost on the order of $400,000 each just for a two-bedroom uh, ranch type house by the time it's constructed. And then so it's going to take time. We are looking at the potential of using multifamily housing. And when we first proposed that, it was not well received at all, but it's starting to be more and more received now. We're seeing in Point Lay duplexes going in, eightplexes going in. In Utqiagvik, they're talking about 20 housing units in a single building. That allows for a number of efficiencies to be able to meet those needs. But if I had to pick one right now, I would say that we really need to get our handles on the housing issues for health and welfare issues.
Very interesting. So, Billy, you mentioned, because in your slide, you mentioned the cultural is an important part of engineering solution. In this case, like you mentioned, like initially, there may be community might be resistant to the like family housing, and then look like they gradually accept this one. So what do you think about the like catalyzing factors that achieve this transition of opinion?
I think one of the things that's occurring, one is, um, for example, in a duplex, the elders can live on one side and the family can live on the other side, but they're still close together. They just basically walk around the wall there that helps that. The other issue is, I think we're starting to see uh, the quality of the housing is actually improving because you can afford to spend more money in the foundations and water systems for that. And I think that the people are starting to see the advantages of that. It's not a new concept, really. The Canadians have been doing it for quite a while now. I visited Selawik and the northeastern part of Canada, and that's most of the housing they have are at least duplexes, but they do have 10 and 20 family units that are there. And that's where we got the idea from. And we've been gradually bringing that into some of the communities, not all.
Thanks. And perhaps have something to add?
Yeah, speaking of housing, I think that climate change mitigation, in order to help reduce the effects of in the increasing severity and occurrence of storms, which is directly related to housing. And according to that report by ANTHC, Alaska needs $4.3 billion of or it will cost $4.3 billion to get the necessary climate mitigation infrastructure in place. And the heaviest cost burden is in Western Alaska, where where the cost per capita is a significant amount of their income.
Thanks. Yeah, maybe also bring up another question, kind of also related to the example, like one of the panelists, like Uyemaa shared, like for example, for decades, the installed renewable energy helped the household run better, right? The mom had more time to spend with the kids because they less need for cleaning, these kind of daily activities. So that's the internet transform internet how like engineering solution appears uh like change the operation inside the house, like in terms of the owner's time allocation.
Yeah. So that was one of the surprising aspects that I found too, that when I was doing the system design and installation, they were very opposed to the disruption that was in their that okay, for instance, so sometimes I will get called at 2 a.m., 3 a.m. in the middle of the night, and they don't have they no longer have power from the grid. And so, and then I will be like scared because they have an infant, and then I will just go there like middle of the night and then try to figure out. And then what happens is that they just had uh that place, that grid had just no power at all. And then they understood that they were always going to have a power, but we were not supporting into the grid. And then we were just supporting that their heater only. And actually in the initially we were trying to support all of their needs, but then their behavior changed dramatically. They started like their home car fixing business because they had like a solar power, and then they started welding, and then we were not equipped. So the switch gear worked, and then they cut off the system, and then they were like, they would call me. I don't know what happened. I'm like, I will go in, and then they would be like, you can't plug this in. So I had to isolate them just to create this offline thing just within that heater. So it's not involved with their any other household generation. So that's only from the grid, but a heater is the only one that's on the. That's the same with the SOM system that one it's about 2,000 people. So when we designed that system, we were just upgrading that existing old system that was not working, that they were 100% running on diesel because it's at the border and remote from everyone else. It takes one whole day from nearest village to get there. And then when we designed the system, they were like they bought bunch of electric equipment because they were gonna have a consistent power. And then I had to up pitch to the ADB and Mongolian government that the demand is gonna be increasing dramatically because the consumer behavior is increasing. And so we had to predict how much they're going to be using and how much we can provide with wind, solar, and mix of battery. And that required, in order for us to fit in the budget, we had to change the battery types to cost save from lithium ion to lead acid back. But then that brings different challenges, environmental challenges that we were not able to handle. So what we figured out was that in order to make it safe, we were gonna recycle or store the batteries after its lifetime has gone finished and until there's a processing facility available in Mongolia. And since it was the Mongolian government project, the utility company that is running that project built a storage in future at the beginning of the project to store that battery in later because it's not going to be on their cost, but we had to quite like look forward 7 years at least, and then put that into the initial construction cost, etc. So, but everyone wants to have this energy independence. Everyone wants that. And then it's like human basic need in our lifetime now to have accessible power and at affordable level and healthy environment. But they sometimes don't know how to use it, or they would have some different expectations. So communication is always the key. I never seen anyone who didn't want renewable energy in Mongolia at least. But we had to communicate what it's going to be, why is it sensitive and all that. So but then it was just sometimes quite difficult, especially working with those low-income families. And then when there's little babies involved, I had a 3-year-old child at the time. My son was 3 years old at the time, and then I would get scared because I know how hard it is to like look after a baby that is living in that air polluted environment. They get like sick really easily, and then I have to take off from work to look after him. I know it's how difficult it is. So I would just jump in out of my bed in the middle of the night and then just manage that. It was so difficult, but then once I like in the spring, once they told me what life changes happened to them, it was quite surprising for me too. So Yeah.
Excellent. So this is like a two-way interactions, like just like in a positive way, for the outcome. Because like I was involved in writing some team proposal for the offshore wind energy. We're looking at like like renewable energies arena, but then some of the barriers like some like a local like a fisherman group was against this kind of plan. So so definitely there's a lot of some like potential lot of barriers for renewable energy adaptation. But then look like from the example you shared, like because people see the value and maybe improve the quality of their life. So that's as an incentive to embrace a different mindset. Yeah.
But one thing I should highlight is that due to the requirement from Asian Development Bank, before we even started approving the project, we did a public consultation with the people that is going to be the local people. And then once we started designing the system, once we approved the financing with the blessing from the local government and community, then we went back. It was an iterative process. I know the budget was just the same thing, but the system design, we could go back in and see and modify it to the need that they currently have. Because the financing uh pipeline is long, but local situations change during that time. So it was one of the important aspects that as an engineer, I had to communicate to all the stakeholders what was important in plain language that they were able to understand and empathize that how it's going to benefit and all that. And then once they understand, then but you have to communicate. You can't just go in and it's like, this is good for you. I know what's good for you. And you can't, yeah, so.
We'll have a question from the audience. In the chat, or if you want to speak out directly.
I think, did you mention, Uyemaa, that you insulated the traditional yurts as part of the project where you were giving them alternative energy? And I'm just very curious about that question. How
Yeah.
did you insulate them? Didn't that in and itself make the yurt much easier to maintain?
Absolutely. Absolutely. Energy efficiency and insulation is like, even before you think about doing anything energy resource generation, right? You have to think. You can't how a pot that is like leaking and keep continuing to put water in it and expect it to hold out. That's the same thing with housing, any type of housing, really. You have to insulate and keep it. We did energy efficiency analysis and we did like the way we insulated is use the local resources actually. We didn't import anything because it's a traditional gear. Mongolians live in it because the local people know what works best for their own local environment. So, but what we optimize is that where should we insulate? Where is it? Like we did heat loss analysis and energy calculation simulations and what is like how much is too much without like how much is too much insulation, because they still want to move around and they still want to be able to, they're still like a dramatic. So, so that we did that, and then it was like in the initial cost, and then because we use local resources and this community, they have this community center financed or supported by Stanford and Harvard. It's called Gear Hub, and then it's one of the beautiful community initiative that my friends are doing that I wanted to help them with. So, and then they did that part. I only provided the calculation once they like and in accordance with those specifications, they hired the community people, severe people, and then created that installation And then once they've insulated, then I went in to install.
It looked like you insulated the yurts. Sorry if this is not interesting to anybody else. Looks like they were insulated to the exterior, so it didn't like reduce the interior space.
Actually, opposite. We insulated inside because exterior they have this weatherproofing shell, like plastic shell during winter, so snow doesn't melt and rain doesn't get in. But what they were losing most heat from is doorway, the entry doorway, and then also the ground was the most part. So we insulated, but it's only like 3/4, like 1.5 inch thick, 3-4 centimeters thick, felt, wool felt that we just put it around the doorway and in underneath. So but it also laid until the ground and then to the wall. So like there is not like a, because we know how cold temperature works within the gear, right? It's always coldest on the bottom and hottest in the top. And then we didn't want that. Like we wanted, and one of the beautiful thing about that, not only the insulation, about this ingenuity of the design, if I can say so myself, is that it's heating the stone, heating the literal brick, and during the daytime. And then so by solar power, it's heating, the electrical heater is heating the stone, that it can store that heated stone safe. The kids can touch the outside, but they're not going to burn their hand. Infants, safe. It's the Mongolians designed that system, that heater, electrical heater. I just gave you power to it, from solar. And then so they can touch it, but and then they can, it's also we installed a temperature sensor, so it automatically starts with the backup battery, and the inverter works together well. And then we also, in order, because we sometimes put the battery inside, in 2 cases of the house, we created this very good insulated shell, because it's a lithium-ion battery. You don't want it to be influenced with temperature variance and humidity variance, because it is a fire hazard. And we controlled that specific, we created this notification system where the temperature in there, when humidity went over the sensor level, because we don't want it, because Mongolian gear can burn in 7 minutes, like everything down burn. So we wanted to be careful with that too.
Thanks. Vera has hands on.
Yeah, thank you everyone for such informative and interesting presentations. My question is, looks like these examples you provided are very, very context place specific. And I was curious if you could react on each other's presentations. Is there any of these solutions would be transferable to your contexts, or are they too specific, or I don't know, very, very culturally embedded? What do you think?
I don't think it's very culturally, like, it's a physics. It's in engineering. It's transferable. I don't think there's culture got nothing to do with the design, but there is this best practices that I could learn, also, and Alaskan communities could also learn from Mongolian communities too. I liked where Bill Connor was talking about the building standards. One thing I noticed coming to US, I don't understand how the walls are functioning okay, because you can like break it with the hand. We have brick walls, cement walls, that is very insulating, And yeah, that's one thing.
Yeah, I think looking at the Mongolian experiences, um, the adaptability, the way that people adapt to changes in the technologies that they're living in, and the quality of life that they're afforded, and you do see a change in attitudes. You see a change in dependence, changes in desire. I've gone into some of the villages that just recently had sewer and water. Uh, Connections to their homes, and all of a sudden, their attitudes towards uh, uh, having that in the home, inside the home, rather than having to haul it, um, makes a huge difference in their outlook on life and how they work. The same with energy, being able to have affordable energy within the home makes a difference in their lifestyles. Um, again, as Bax said, the issues of facing us with the climate changing, the the coastal erosion in West. I mean, that's going to be difficult. We're faced with some very hard choices. Do we retreat? Do we adapt in place? How do we manage that? And um, I think we're being forced to look at some of these issues more holistically. I think Mongolia is starting to do that as well, to try to understand how to look at it instead of bits and pieces, how to look at our infrastructure more holistically.
Yeah, excuse me. Yeah, I want to add on that I learned recently that we often underestimate how much people know about their environment that they live in. And and a lot of areas of Alaska with like high winds, they're too energetic. They're too windy. But and we should listen to the folks that want wind energy to put them where they want it to be and not where it's most energetic because of weather windows for maintenance um, or things like that. When people um, learn that you listen to them, they trust you a lot more. And I've been exposed to several failed renewable energy products or projects, and those failed like 10, 15 years ago, and people still don't trust them. So making sure that you listen to the folks on where they want things. And I do apologize if there's any national labs folks here, but the the it's that's where I've found it's been most difficult to communicate that like, hey, instead of putting this technology where it's most energetic, let's put it where the folks want it. So yeah, being able to listen to the folks and to incorporate their feedback in system design means a lot to them. Oh, and I do want to add one more thing on policy. Um, so I don't know how it is in Canada or Mongolia, but at least in Alaska, rural energy prices are subsidized by the metropolitan areas. So what that means is that even if folks are installing renewable energy, uh, because of the way energy policy here is in the state, those savings don't get seen by the consumer because it's subsidized by PCE. I know of folks that are working on changing that, but that's just another layer to the problem cake, is how energy policy is implemented in each region. So in other words, uh, renewable energy in rural Alaska is not incentivized.
And this is interesting observation. So policy, like look like play a very big role. So any other questions from the audience and also from panelists? So Billy, maybe from the one of your slides, you show a photo about like some like a water tank, look like a water tank under the ground. Is that like some challenge, engineering challenge you try to highlight with this photo?
Well, I can certainly spend the rest of the day talking about, for example, Point Lay and the issues that they've had there. They put in, I think it was like an $80 million water and sewer system underground. It failed after 12 years, and so they haven't even paid off the bond yet. And so they had 70 houses connected to it, of which I think they've got about 15 left that are connected to it. And so they had to quickly adapt. And in order to adapt, what we came up with was what I call a tank and haul. Basically, they put a water tank and a sewer tank on the ground. They insulate it and they connect them to the house appropriately. And once a day, they come fill the water tank up and haul the sewage away. But it's interesting the way it's set up. Um, once once the sewer tank fills up, it trips a switch, and now they can no longer get water. So they can't overfill the sewage tank. And that's what they're living on right now. They're working on the design for an above ground system, which is quoted somewhere between 140 and 170 million dollars, and that's for a total of 700 people or about 70 houses.
That kind of sounds interesting. It's like I think all three panelists mentioned about like water sewer related issue for the Arctic, like a cold region community. So you mentioned like, is the water tank stored above the ground in the long
It is stored above ground in a heated tank,
heat tank? Oh,
and that tank is insulated. But I want to also mention while we're talking about sewer and water, um, I think there's 189 communities in Alaska at present, and of those, 36 have no running water and no sewer. And so what they use is what we call a honey bucket, which is basically a toilet seat on a bucket. Um, and uh, Wales, which is on the northwest coast of Alaska, last winter, they're on a honey bucket system, and they could not haul their waste to the dump because they didn't have a piece of equipment to clear the road. So it ended up sitting out on the street corner. Those are the kinds of things that we're facing, really third world country issues that we're facing.
maybe the solar panels and the renewable energy can play a role for the heater, right? But water tank heater, it's a locally available resource.
Yeah. A number of the communities are getting wind energy, and a few are getting solar. So it's gradually creeping in.
Looks like this conversation can continue for long. And yeah, I just wanted to thank everyone. And if someone wants to continue conversation, we can keep this Zoom open for a few more minutes. Otherwise, we welcome everyone to attend our next webinar that will be scheduled on February 3rd at 1 p.m. Eastern Time. It will be dedicated to studies of biophysical aspects of infrastructure. And yeah, thank you for a very interesting discussion. And the chat discussion is also very interesting. If anyone hasn't noticed yet, there are many useful links and resources that we can all check out. So yeah, thank you.
Thank you.
Xiong, do you want to
Thanks.
say anything?
Thank you.
Thank you. Hopefully everyone could hear me okay.
Yeah,
Yeah.
it was great. Yeah, thank you so much.